There's always a bit of technical difficulty. We're here today to talk about something that's near and dear to my heart and hopefully something that's important to you guys as well, and that is the diagnosing of problems in landscape trees. I think one of the greatest concerns as newer plant health care workers we experience is that we walk on a landscape and it's not completely obvious what is wrong, and our customers are expecting us to solve that problem. So I'm going to take you through a number of things today that hopefully will give you more of a structure to what happens when you walk on a landscape. And of course, if there are questions that come up along the way, please type those in for Zach or save them till the end, and we will allow you to ask them as well. So thanks very much for joining us. We'll get started. All right. So how do we begin the evaluation? It's an important question. Let's just talk about what that looks like. As soon as I can get my cursor to begin working, we'll be in great shape. There we go. So typically, you get a 911 call, or you're out on a landscape reviewing it for a service, and you discover a problem. Usually it's a tree that's in decline. Hopefully it doesn't look like the one on the right. And often, for the customers, it just happened, and now what? How do you begin to assess what it could be? So let's talk about that today, discuss many of the possible issues, discuss some of the common symptoms, and I'll make note very early, buy yourself one of these 10x magnifier loops. Comes in really handy on seeing a whole lot of stuff that you can't see with the human eye. So in general, one of the biggest problems is that companies lack the personnel to designate a specific trainer, or the trainer has multiple roles. Most small companies are in that situation. Perhaps you are as well. Seminars like this one, and some conducted by the TCIA each year, help to accelerate that PhD learning curve and really simplify the diagnostic process. Frankly, you can't wait 30 years to become excellent at diagnosing because no one has that much time, and no one has that much time to wait to get an employee or a highly trained PhD worker ready to go. So bear with me. I do seem to be having some trouble with progressing through slides. Let me try something a little different here. Okay, let's see if this continues. So, Diagnostic Solutions. Insects, fungal and bacterial diseases, site conditions, soil quality, soil volume, and planting errors all contribute to tree decline. So, in order to be as confident and avoid being overwhelmed, each diagnosis needs to be systematically applied instead of just looking at the entire landscape and all of the problems and sort of panicking about that. You need to narrow and consider the possible causes of plant deterioration. And what helps is to learn the diagnostics, identify the signs and symptoms, and narrow the scope of possible causes. Once you do that, suddenly you don't have a massive problem. You've got a much more defined problem to solve. And the goal is to deliver practical, environmentally sound, and successful intervention strategies that are going to protect and ensure the long-term survival and health of plants. So let's just catch up on a few definitions before we jump right on in. We need to define the difference between a sign and a symptom. A sign is visual evidence of the actual organism. So it's either going to be some part of the disease, the fruiting body, the mycelia. In this case, you see the fruiting body on a juniper. And so that's a sign of the actual organism. There'll be some stage of the insect potentially, the larva, the adult, the egg, the pupa. All of those are defined as signs, actually seeing the organism that is causing the problem. We get to symptoms. This is the effect of the pest or the disease on the organism. So you'll see evidence of feeding, or brown leaves, or decay, discolored wood, slower internodal growth, and we'll talk about that in a moment, or smaller plant parts. In this particular case, you can see the galleries from an insect that was boring beneath the bark of the tree. These are all symptoms, not signs. So when we talk about a disease, it's a progressive disruption of normal functioning in the plant. It could be isolated to a plant part, a stem, a twig, a root, a leaf, or it could be systemic, involving or invading multiple structures all at the same time. Most diseases are typically fungal or bacterial, and most tree decay is caused by fungi. Bacterial attacks will often begin in the leaf tissue, but they can progress into the twigs and stems as well. And of course, weather conditions often play a significant role in the spread of diseases, as many of the diseases require moisture, humidity, or water to multiply and spread, because they typically spread through spores. A few more definitions. Insects and mites. They're relatively small. We've all seen them. The adults typically have 6 to 8 legs, depending upon whether they're an insect or a mite, and they're typically segmented. And the life stage of an insect can either be an egg, a pupa, a larva, or a nymph, or an adult. And it helps if you are able to begin to identify just what stage you're in as well. That'll also determine whether or not we can even treat for the problem. Typically, only one stage of the insect is damaging to trees, either the larva or the adult. But in some cases, both the larva and the adult can feed on different parts of the tree. I'll use emerald ash borer as an example, where the larva feed underneath the bark and the adults can feed on the leaves. But typically, it's only one stage of an insect's life that actually causes the most damage. Keep in mind that insect predators feed on tree-damaging pests, so you need to know what these pests look like, and it's helpful in determining if you have the prey or the predator that you're trying to control. And of course, there are several different ways that insects feed. Again, just in terms of defining some of the basics here, leaf skeletonizers leave the leaf veins intact, as you see here with the Japanese beetles. Chewing insects are like caterpillars and beetles, and while they may not prefer the veins, that doesn't typically stop them from eating through the entire leaf. In this case, that's a gypsy moth. Sucking insects will extract nutrients from the leaves or needles and often cause a stippling that you can see on that sycamore leaf to the right. While boring insects feed or bore into the xylem and phloem inside the tree beneath the cambium to either receive nutrients or to reproduce, lay eggs, or grow. Those are our 4 basic groups of feeding, although there are others that sort of cross the line. On top of all that, cultural conditions can often mimic diseases. So you'll get a site condition that is causing the tree to look bad, and it's actually got no causal organism, but it still puts a strain on one or more of the tree systems. And the end result is that the trees decline, and you notice it, and the goal is to try to figure out what's going on. And while the lack of a causal organism might seem okay, the fact is that many times the result is as bad or worse as if there was an organism there. Site conditions can limit root development, kill roots, reduce the adequate photosynthetic surfaces. It impacts food and nutrients as well as water movement. And we're going to talk about a lot of these as we go along today. Nutritional deficits, grade change, root damage, pruning injuries, and weather extremes. So I think the key is to consider the big picture as you begin to assess a landscape, as you arrive at the landscape. And I'll readily admit that there are times where you're going to pull up, and the reason they called you is the same problem that everyone else has in the area. Some major pest is posing a serious issue for the entire community. And in those cases, it may be very obvious to you what is going on. But in many cases, that is not what happens. You're coming into a situation where you just don't know for sure when you arrive. So one of the first most important lessons to learn is that if you know what the tree species is, you're going to immediately limit the types of problems that you may be looking at, because that's the first step in diagnosing what's wrong. It's really very simple. diseases and pests are often specific to the trees they attack. So some trees prefer sun or shade, some prefer wet or dry conditions, others acidic or alkaline conditions. Knowing those things, if there's no causal organism, may help you to figure out, we've got the wrong tree growing in the wrong place. This is what our problem is. I'll recommend that you check out the Virginia Tech Tree ID app that's available at the app stores on your phones. It's a wonderful tool to help you narrow down and identify the tree species that are growing in your area. I've used it regularly, and I think it's a pretty neat tool. There are, of course, others. So the next thing to figure out beyond tree species is the extent of the problem. Is it confined to a single tree on a single property, or is it widespread around you, such as a large outbreak of a particular pest or disease? So the things to consider are site issues, the grade, moisture, the depth of planting, herbicides. Is it only occurring on the front of the property, the back, the side? Is it reaching into a neighbor's yard? Just how narrow is the problem, or how wide is the problem? And then we look for patterns. This is something that is really going to help you with some of the more weird situations you run into. So in this case, I'm talking about the fact that most insect and disease problems are not linear. They are not geometric. There are no sharp right-hand turns. There are not any of that going on. Inevitably, if that's the case, something has happened either to the plants or as a result of disturbance of the soil that has caused a wide-ranging set of problems. One situation I ran into was a gas main leak that ended up killing every tree and shrub within a specific vicinity of where the gas main leak was. And no one could figure out why that had occurred. But it was really obvious it was very much a centered or focused problem. So look for construction evidence, turf disruptions, and shrubs nearby. Do they look okay? Are they doing fine? What is occurring in the yard? The other thing that's really important is the speed of decline. How long has the plant been declining, and how can you tell? Again, this is where internodal growth can be an enormously useful tool, and I'll get into that description in just a moment. Is there damage to the bark? How much damage has occurred to the bark? Trees can withstand an enormous amount of damage as long as they're not girdled. And if they lose all of the bark around the tree, no matter how thin that area is, they may very likely die. Is it evident throughout the tree or on one side of the tree? Are there disruptions to the soil near the tree? Do you see new turf planted and have to wonder why? Is there root destruction that has occurred? Additionally, another big picture thing is to look at the history of the property. General knowledge of the weather and environmental extremes can give you some clues. Have there been floods, ice, snow, drought, fire? How close are they to the road? Has weed control been used? I've seen situations where weed control is applied to a rocky area and it is moved 30, 40, 50 feet to kill oak trees. A little detective work is always necessary in some of these more difficult ones. And by all means, ask the clients. They may help to fill in blanks. It really is very useful when you've exhausted all the other possibilities. So let's talk about internodal growth. Each year, if you look on the right side of the picture, a bud forms, an end bud that is going to break dormancy the following year. That bud has bud scales on it, and those bud scales create scars on the plant, on the branch, as they break open and continue to grow. What you can see here is that there are approximately 6 to 7 years worth of growth in this one branch, the uppermost piece, and you can discern that by looking at those bud scars. Measuring the distance between bud scars and whether there is a change in distance between bud scars can tell us, is the tree growing very well? Is it speeding up? Is it slowing down? In this particular tree, it happened to be a Norway maple. It was growing in a very dry area, experiencing the stresses that the summers back in the 1990s were creating, and the tree was struggling. This 7 to 8 years worth of growth was in about 3 inches. And so this tells me exactly what is going on in this tree. It is struggling. It has been struggling for at least 7 or 8 years, and I don't have the rest of the picture to tell you if it goes back beyond that. But the next question is, What are we going to do about that? What can we do about that? But this is a very critical thing, and I'd encourage you to, if you are able to look at internodal growth, check both sides of the tree because not all branches grow evenly. So before you make a diagnosis, check a few places to make sure that you're confirming your diagnosis. So, to summarize what we've assessed so far, the trees that were involved, is it a single species or several species? Does the problem exist only on this property or throughout the area? Does it exist on one tree but not on others of the same species on the same property? If your conclusion is that the problem exists only on this property with one or more tree species affected, then you may want to look at site conditions for the possible answers. So what do we deal with site conditions? Man, they are probably the #1 cause of tree decline that we experience on urban landscapes. Grade change. This is where soil is either added or removed from the existing tree, resulting in root death, and you'll typically see either no trunk flare or you'll see a bunch of exposed roots. And this tells us that something dramatic has happened because these roots are not laid down specifically in a random manner, but they're positioned by the tree in a place where they can maximize the oxygen exchange and adequate moisture. And when we change the grade, we kill a lot of these feeder roots, the roots that supply this tree with adequate nutrients and water to continue on. When we look at girdling roots, this is a really blatant example, hard to miss, really obvious, but so many of them are not quite so obvious. This is a big problem in container stock where the roots tend to swirl in the plant the longer it's been in the pot. And they're often visible above ground, not this way, but rather from a flattened part of the trunk where the trunk just does not look the way the rest of the trunk looks. And often digging around at the base of the tree, you'll discover this girdling root. Then there are site conditions that go on beyond this, excessive moisture or drought. Both kill the feeder roots and reduce tree vigor and increase susceptibility to disease or insect attack. It reminds me of when moms used to tell kids not to go out and play in the rain. It had nothing to do with the rain. It had everything to do with getting stressed out and being more susceptible. So what we're experiencing in these situations is a reducing vigor of the tree, the loss of feeder roots, and an eventual decline over time. Soil probes can be a really, really massive help to you in dealing with these kinds of issues, both excessive and too little water. You may not be able to get the soil probe into the ground even a few feet away from the trunk of a tree, or you may put it in the ground and come up with soup as a result. These can all be very helpful to you. Soil types can exacerbate the problems. So if you've got excessive clay, you've got one set of issues, sand another set. Clays do not like to get wet once they've been dry, and they don't like to dry once they've gotten wet. And sand, unfortunately, holds almost no water at all. And so a few days in a sandy site without rain can mean drought stress conditions appearing. And the last part about this that I think is important is what happens when anaerobic conditions occur. This is simply meaning without air. And when you stick a soil probe into an area that is excessively wet and you pull that probe out, that soil will smell like something is rotting. It will smell sulfury. It will smell bad. And that tells us an awful lot about what's taking place under the soil. In this picture on the top, you can see the result of severe drought stress. And on the bottom, this was a situation where this tree was under stress because it had too much water, and it was a new transplant. So the needles that are dropping off, while that is normal, in this case they were excessive. And that told us that something bad was going on under the soil. So let's look at chemical injury next. Some insects can mimic herbicide injury, so you've got to be careful in recommending before you make a verdict. You may see cupping or parallel venation, yellowing or stunting of the leaves. You might see tip burning, interveinal browning, or irregular leaf dieback. Sometimes the proximity to soil sterilant applications is a good clue. But you have to be cautious. If you look at the picture on the top, that damage, which mirrors the result of chemical injury, of herbicide injury, is actually aphids. However, a careful examination would show us the aphids typically underneath the leaves, and so a little bit of extra work would help us. So further, winter injury. In many parts of the country, this year was a particularly severe year for winter injury. Frozen soils, desiccating winds, snow load, ice damage. In addition to the damage these things cause, they also invite further pest attacks as well. Mechanical and pruning issues. The crushing of roots from construction often result in slow, years-long tree declines. The picture on the bottom right with the rather enormous truck also shows a tree that has ribbon wrapped around it to say, we're keeping this tree. And the reality is that they're keeping that tree for a few years. They just don't know it yet. So recent construction, mower or weed whacker injury, like the dogwood on the bottom left. The entire tree was girdled and they couldn't understand why it died. Pruning errors, things like clean cuts, all of these things contribute to decline that you have to figure out and identify as you go through your chart of the things that could possibly be wrong on a given site. My favorite, mulch volcanoes. I'm not sure we haven't heard enough about that, but trunks need to remain mulch-free. Everyone adds it because it looks pretty, also to keep the weed whacker away or the mower away, but a lot of companies go absolutely crazy. I've seen as much as a foot of mulch on top of the bark. Bark is not meant to stay regularly wet. You'll often see cracks. You'll often see disease entry. It will kill feeder roots when it's suddenly applied on top of the soil where feeder roots have been growing. And frankly, if it's there long enough, the tree will attempt to recover by growing shallow roots inside the mulch. So removing the mulch could be bad at that point. Keeping the mulch could be bad because if it dries out, the feeder roots dry out as well. So 3 to 4 inches maximum on this root system, and keeping it away from the bark is the rule of thumb. Plant location. Many flowering trees, the ones we enjoy putting in the front yard, are understory trees. They prefer shadier, moisture conditions, not where we place them, full sun, hot. When you place them in the sun, they're stressed, and that means that there's an increased susceptibility to pests. Things like the trees such as birch and dogwood and redbud, all placed in the sun, end up going through enormous stress and risk being killed as a result of the wrong tree in the wrong place. In this particular case, those happen to be mountain laurels, which are a beautiful specimen in some areas of the country, but you'll notice where they're naturally growing in that forest as an understory in the shade. That's an important lesson for us. Mixing soil horizons. I have not seen a new construction site where I've been completely confident that the quality of the soil going back down is the same as the soil that was taken up. This is perhaps one of the more dramatic pictures I've taken of this, but you can see how much garbage is mixed in and how light that soil is. Clearly that's B or C horizon soil being mixed in and over the top of an existing tree. But you can imagine if you plant new trees into that stuff, there's very little soil biology, low fertility, compaction, and the tree is in trouble from the very first day after it's planted. In this case, this tree is destined to die because it's got 2 feet of soil laid over the top of half of the trunk. Sometimes it's a good idea to import soils. You may increase fertility. You may be able to supplement using products such as NutriRoot, my one and only plug for a product today. They can be added to help with the missing nutrition. But by all means, be sure the planting holes have adequate soil and adequate quality soil, not these mixed A, B, and C horizons, which so often occur in new construction. When we talk about pruning, many of us understand the concepts. Proper pruning, limiting excessive growth, thinning purposes, repair pruning, and restorative pruning. But excessive pruning limits a tree's ability to photosynthesize and can result in an imbalance in the tree's structure and stability. We've seen a lot of incidences this year of trees being blown over in storms along the East Coast. I'm not saying it was all because of the poor pruning that has been done. In many cases, the trees were already in severe compromised conditions. But by lifting the branches, meaning you're removing so much of the bottom, you often put the trees into an unbalanced situation. And I'll point out one more thing here with these two pictures. The concept of branch collars. Many of you may be very familiar with that. But just the other day, I drove past a house that had been clean cut so that there were no little stubs, no branch collars left on the trees as they were pruned. It is very clear that the way the tree recovers from a prune is to prune beyond the branch collar just enough that the branch collar can grow over the top of it. These are the kinds of things that you can avoid and hopefully that you won't find when you walk onto new properties. But this whole concept of clean cutting and leaving branch stubs or damaging the branch collar serves as potential entry points to diseases, insects, and also allow water to come in and sit. Let's talk for a moment about nutritional deficiencies. We don't see this all over the country. In the far west, in the far east, along the coastlines, this tends to be less of a problem. But in alkaline conditions, trees are too often planted whose needs are ill-suited for those soils. So the associated mycorrhiza can't function properly. An important thing that I learned very long ago in a field down in Georgia while I was in school was that two different groups of clay overlapped in this field. One was an alkaline clay, one was an acidic clay. And on one side of the fence row were alkaline-loving trees, and on the other side of the fence row across the field were acid-loving trees. And it was explained to me, because it was a soils course, that the real issue was not the soil or the pH. It was that the mycorrhiza that are associated with those different species could not live in those conditions and therefore couldn't function properly. So often we see maples and oaks and camphor and birch that have chlorotic yellow and brown leaves, stunted growth, or interveinal yellowing. It's not just an appearance thing. These trees are struggling. When you get into high alkaline conditions, we know that they tie up the soil micronutrients, and that makes them unavailable to the tree roots. When you look at that nutrient chart, you'll see that iron and manganese and boron are some of the three major nutrients that are in the micronutrient family that get tied up in alkaline conditions. But in acid conditions, detecting nutrient deficiencies is more difficult and subtle. I'll recommend you look at that picture at the top of the oak leaf. From the distance, the tree looks still relatively green. It's only as you get close that you begin to see that there's this interveinal chlorosis and that there's a problem. What we discovered on this particular site was that it was about small imbalanced quantities that were off. And what I mean by that is that when we did the soil test, we discovered that the iron and the magnesium were, the iron and the manganese, I don't know, that's an error. Iron and the manganese were imbalanced. Way too much iron, too little manganese. And the result was the tree could not function properly. So soil testing is a start, but you've got to interpret the tests in a critical way. It's not just about nutrient levels, it's about balancing the bases, and that can be a problem. And that's where it helps to refer to the lab, to talk to the lab about the possibilities, and be sure to mention that your soil samples are under trees, not for the lawn. Now, changing the plant is an option, but let's face it, if a tree's been there for a while, the last thing you want to do is recommend removal and replacement. Correcting soil characteristics, including soil biology, microbes, bacteria, and fungi, frankly, they're pretty difficult after a tree is planted. Sure, there are ways to do that, but it is not easy. And the debate over adding mycorrhiza continues. Some people claim benefits. Others suggest that trees which require them, well, they either have them or they would not still be alive. And by the way, for those of you that have not really studied mycorrhiza, these fungi are associated with tree roots, and they help the trees to absorb nutrients and water, so they facilitate the health and growth of the tree. Adding micronutrients to soil can be helpful, but if the soil pH remains high, if the basic material of the soil is alkaline, then the key nutrients run the risk of being tied up yet again. Or in sandy sites, they'll wash out. They simply won't stay at all. So that means that you need to be applying more frequent amendments just to solve the problem. We started experimenting with a brand new product, and lo and behold, we saw amazing results, and I felt it was worth sharing this with you because I'm just so delighted. I had hundreds of these pictures done down in Texas where trunk injection of the micronutrients produced long-lasting results in healthier trees, even when applied at lower rates during the summer months when we often stay away from the idea of adding any micronutrients to a site. As you can see, these were a fall application and the following spring, an amazing turnaround. So, I know, you know, anxiety exists when you've got a myriad of insects and diseases, and then hoping we can identify the problem. Knowing the tree species helps, as we talked about. Few pests kill trees, and many pests are specific to the species or genus attacked. EAB only attacks ash. Pine beetles only attack pines. Oak wilt attacks oaks. It can really help you to limit what the options are when you know the tree species. Most state extension offices list common tree pests for your area. Ask them for those documents. Go online. You can often print them out. And if you get into a really tough disease problem, most of the state labs, most of the state extensions have a lab to diagnose tough tree problems. You can use search engines and apps. This morning I typed in diseases of sycamores, and immediately anthracnose pops up. And then it says that London plane is far more resistant to anthracnose. I typed in diseases of palm trees, and it immediately popped up Ganoderma as a major problem with trees, palm trees in Florida and the southeast that cause them to die. There's a lot available. If you haven't downloaded our app yet, it's called Arbor-Mobile. Be sure to put the dash in there or you'll get a bank. And that can also help you with some of the major problems and recommended solutions. So there can be multiple issues causing tree distress and decline simultaneously. It's not always just one thing. So following a process, as I'm suggesting today, can prevent missing one or more problems. This is the kind of chart that I often like to recommend. This is just one example of the kinds of reference sheets that are available to you, where you can find out what the insects are, what species they tend to be, what tree hosts they attack, and possible recommended solutions. This is not the only one, but this is a tool that's available to you both from Arborjet and in other places. So, you've reviewed site conditions. You stood back, you've looked around, you've reassessed the broad picture, and you're trying to get a sense, is it the site or is it something particular with the tree? So what do we do next? Well, get close. Examine the crown, where the tree meets the ground. Look for any trunk flare or a lack of trunk flare. Does the tree go straight into the ground? If it's a really young tree, you might not notice any trunk flare. If it's a maturing tree, now you've got a problem if that tree goes straight into the ground. Somebody put soil on top of that tree at some point in time. Check for wounds. Tap to detect hollow areas beneath the bark. That upper picture, I tapped the bark and came upon this site and discovered that everything was dead underneath it, and pulled away the dead bark that was over that site just by tapping on the tree. Look for sawdust, small holes, sap flow, and for any evidence of the insect or the disease. We're talking here of the actual sign, not the symptom. Are there visible signs of fungi? Are there mycelia? Are there mushrooms or conchs? In this particular picture, this was southern pine beetle. I took this picture in New Jersey. Not only did I have first and second generation sap oozing out, the darker red and the cream color, but on close examination, if you can see it, there's one of the southern pine beetles just below the hole on the lower section. So I had all of that to look at when I was trying to figure out what was wrong with this tree. Examine branch and growth and elongation for signs of vigor. We talked earlier about the internodal growth. How is it looking? Examine the lower branches as you move up. You know, you may not be able to look at them directly. You may need binoculars. Get yourself a good pair. They will save you a lot of guesswork. Look for galls. Look for chewing on the leaves. Look for chewing on the branches. Is it physical damage? Is the bark darkened, indicating that it could be sooty mold, which means that we've had insects that are sucking insects, excreting the honeydew onto the tree, allowing sooty mold to grow. What is this telling us about what's going on, even if we're not in the season where those insects are present? Examine the leaves. Is size normal? Are they laced? Are they chewed? Are they missing entirely? Are they blackened? Do they have growths? Are they discolored in areas? Are there circular areas of concern? Fungi tend to grow in circular areas. This tar spot on this maple would be a real serious concern in a wet year especially to the homeowner. But in reality, it's not a serious problem. Knowing what is and what isn't helps you to make good recommendations to your customers. By reviewing all of this, it allows you to compare key issues, symptoms, and/or signs with tree species, and then to consult the references to narrow the problem and eventually make recommendations. If you get lucky, the diseases or the insects are actually going to be there. You might find an adult, a larva, a pupa eggs. You might see the fungal growth, a fruiting body, or mycelium. This really helps in your ID, even if you're unsure of what that stage is, because then you can go back and refer or check an active website on your smartphone. This is why knowing this kind of stuff and having a pest makes the reference material so much easier to use. And if you're seeking help and you're going to send pictures to somebody, please include a variety of clear shots. Check the photos first. If they're blurry when you look at them, they're blurry when you send them to the next person to look at them. Another great site I like to visit is bugwood.org. It's a site that's run by the University of Georgia, and it has thousands of pictures that we all can enter and share of a myriad of pests that are available to help you figure things out. And in case you didn't catch it, we've got a pest sign with Japanese beetles, because we've got the Japanese beetles. We've got the fruiting bodies of Ganoderma in the center. But if you look at that picture at the top, clearly something's been feeding on the leaf, but that's not a sign, that's a symptom. That happens to be emerald ash borer feeding. We're not looking at an insect there, so we really can't be sure without going further exactly what's going on. And that was just a design to, trick you just a little bit. So let's put it all together here. You've assessed the site. You identify if it's a cultural problem, an insect, a disease, or some combination. Then you've got to decide what can or should be done. Some cultural conditions are correctable and some are simply not. Let's talk about a few of those for now. One of the biggest problems we all run into is trees that are planted too deep. And unless it's a recent planting, the feeder roots may have already begun to die from the improper gas to water ratios. Now, removal of soil can be an early option, but often trying to do that after the fact when all the feeder roots are dying is a hopeless adventure. Pruning errors, they're often hard to correct, and they extend beyond today's webinar scope, so we're not going to talk a lot about them. But if you don't know about pruning, I will tell you that the ISA is looking to actually create a certification program in pruning. I think it's a wonderful idea because so many problems exist because of improper pruning, even if well-intended. Grade change, like planting too deep, just adding more back on to correct for a shallow root system, as you see here, can kill a tree. A mature oak tree could die with just 6 inches of soil added back on. So you can fix these kinds of erosion problems, but very slowly over time. Mulch depth, we talked about that. Sometimes it's a simple case of pulling back the mulch away from the tree. But what do you do if you find problems? What do you do if you find roots in the mulch? How is it best able to be approached without causing additional harm to the tree by desiccating the roots that are growing in the mulch? I would say in most cases, the advantages of removing the mulch and leaving a small thin layer outweigh the disadvantages of additional roots dying in that area. Because the biggest risk is that the bark will crack from being wet constantly, diseases will get in, and the tree will die. So given the alternative of losing some feeder roots versus a tree dying, I think the options are obvious. And when we come to moisture, how do we deal with that? It's easier to address limited moisture with products that control volume, like drip irrigation, or that retain soil moisture, such as a product like NutriRoot. It's harder to address overwatering and waterlogged soil or heavy soil, especially after tree planting. And again, that's where the soil probe can be so helpful in identifying a problem as you come upon a property. So what are some of the alternatives? Planting in mounds can be a great solution in situations where you have no alternative in very wet conditions. Mound planting can be the difference between life or death in young plantings. Girdling roots. Trees in compacted or clay soils, or often container grown, are going to be at greater risk of developing girdling roots. But you've got to assess the cost-benefit of root removal. If you remember that picture I showed a bit earlier, the last thing I think I'd want to do is to cut all of those roots off. I'm pretty sure I would lose a significant amount of my feeder roots as well. So you've got to decide before you move ahead with root pruning what kind of an impact it's going to have. Of course, if the girdling is so severe, you may lose the tree regardless. So it is a gamble. Again, how large, how impactful the girdling, and do you have adequate tools? On chemical injury, it's a tricky one. For those of you that heard about the Auburn University loss of some of their live oaks due to a really upset Alabama fan that used a soil sterilant, that problem continued not just for the trees that were there and eventually were removed, but even for the new trees that were replacing them. It's been an ongoing problem for years now. Some issues are more superficial, so that a volatilization, evaporation of an herbicide onto leaves, sometimes it's relatively minor. Others, like an actual drift or soil sterilant nearby, could damage or kill. And while excessive fertilizer has been known to kill trees as well, the good news is that usually the problem is not insurmountable, and there are abilities to use soil remediation to try to fix the problem, including charcoal and also leaching out the improper salts, because the burning from fertilizer is the extraction of water from the roots because of the osmotic principles that exist. So the water is trying to balance the nutrient load inside the roots and outside the roots, and it desiccates the roots, causing burning. Winter injury. Well, again, lots of that this year. Ice, snow, desiccating winds. They're worst on broadleaved evergreens and also some zone marginal ornamental conifers. That tree on the right-hand side is a blue Atlas cedar. It's marginal above zone 6 and suffers typically from desiccation and wind burn in the cold weather. The good news is that those needles are likely to drop and be replaced, so not a serious loss for that particular kind of tree. I'm going to recommend soil nutrition after the damage, adequate moisture, and selective pruning where and when necessary. You can also consider fall treatments with antidesiccants. If you're taking this customer on as a new customer, making sure that there is adequate moisture going into the fall, or consider water holding products like NutriRoot, as I mentioned earlier. They can help prevent recurring damage every single winter. Marginally hardy plants may die, and this is very important. Again, for those of you in the northern part of our country, we've seen some extreme temperatures this year. When the spring arrives, everything may look fine, and these symptoms may not show up until late summer, long after everyone has forgotten about winter. So be on the lookout as you go out this spring for trees that look like they may have been hard hit, because those trees, especially ones that have leaves on them through the winter, are at great risk, or if they're marginal for the zone that you're in, of dying later on in the season. There are lots of ways you can control insects. First step is to determine, do I need to control these insects? Are they damaging or disfiguring the tree? Will it die if I don't stop the pest? Does the client actually want me to address the problem? Another thing to consider is, can it be controlled? Maybe the timing is wrong. Maybe it's the wrong time of the life cycle. Do I have the correct equipment? Is this the right time to treat? I've had people ask if they could treat for gypsy moths, which are in the egg form over the winter, by treating in the fall. The answer is no. You can't spray the trees. You can't protect the trees in the fall to control the insect in the fall. Although I will say that injecting the trees in the fall can protect the trees when the leaves come out in the spring. Soil injection is easy, but it has per acre limits, and there are off-target risks. Bark sprays, again easy. A bit more exposure to the applicator, also per acre limits. Cover sprays, the biggest issue we face today is that people don't want us spraying the neighborhood. Years ago, when I sprayed trees for a living, it was almost expected that I would be covering the neighborhood with my sprays. No longer accepted. And most spray rigs today average a 30-foot height instead of the 70 and 80 feet needed for some of the tall trees. You have weather issues, longevity issues, timing and efficacy. It may work best for use on leaf feeders, not as well for insects that are internal feeding on the tree. There's trunk injection, and there are several methods available there. Many companies, caps, microinfusion, macroinfusion, and cambule injection. The thing that I am most proud about with trunk injection is that while it is able to control most insects and diseases and mites, it is often the most effective method for stopping borers, which often kill. Things like pine beetles and emerald ash borer and polyphagous shothole borer, bronze birch borer, and two-line chestnut borer are all more effectively controlled from inside the tree than we ever had the tools for when we were trying to treat the outside. So, diseases attack leaves, twigs, trunks. They range from aesthetic to life-threatening. We all see these, and we don't realize when we look at them initially how severe the problem is going to be. Many of the more difficult tree problems today are from what are called insect vector diseases. And that's where the insect brings the disease, which is usually a fungus, to the tree. The fungus is the food source for the insect. And it can block up the tree's vascular system, and it can even kill the tree, even if you control the insect. That picture on the right is in California. It's polyphagous shothole borer. You can see the large number of hits this tree has sustained. And the difficulty is that it brings the disease with the insect. So these pests require a two-pronged approach to control, using long-lasting insect control and disease control. And trunk injection has demonstrated the most effective outcome for this problem, because we now have to put two separate insect and disease controls into a tree to try to protect this tree from within. So diseases fall into two main groups, fungi and bacteria. Often you'll hear us talk about suppressing bacterial diseases, not eliminating them. This is important in your diagnosis because if you run into a bacterial disease, like bacterial leaf scorch, or, the rest are eluding me at this moment, it is important to understand that you cannot simply cure these, that you can control them and suppress them for a year. Fungal diseases, on the other hand, may be cured, prevented, or suppressed depending upon the type of disease. You need to assess them for their potential to cause severe damage or to kill the tree. Leaf diseases like leaf spot often cause minor damage and are pretty well tolerated by most plants, while some diseases may kill leaves, causing the weakening of the tree and stunting of growth. You can see the armillaria root rot there on the top picture, and that is a killer of trees, whereas the apple scab on the bottom is very likely to cause some defoliation. In fact, it could be severe, but the trees seem to power through that and are not nearly as impacted, and most of them do not die. Other diseases will move from the flowers to the leaves and the twigs, and the most difficult and often fatal diseases are those which cause trunk rot and wood decay. I'll mention this to you. Getting into the specifics is beyond the scope of this webinar, but there are lots of great resources for tree diseases. As I mentioned, your local extension, the TCIA, your Arborjet technical manager. You can see us and look at our website at arborjet.com. But I want to mention this really great book that I bought on tree trunk diseases. It's called Wood Decay Fungi by Christopher Lee. This has got lots of great visuals and shows us all of the spore bodies, the fruiting bodies, the conchs, the mushrooms, and the trunk rots and the crown rots. And it's important to know these because most of these are not curable once the tree is in fact infected. Some insect vector diseases also include disease complexes, where you'll actually have several fungi species together with an insect, and those are even more difficult to manage. And as many of you are probably aware, fungicides are classified as contact or systemic by their ability to penetrate, and are often chosen by the type of disease present and the need to control internally or on the surface. So to sum things up, many declines in urban landscapes stem from the wrong tree growing in the wrong place in poor conditions. But what's easiest to ID and fix are insect and disease issues. If you follow a deliberate, strategic, and encompassing view of the property, you'll uncover hidden and future plant issues and reduce the likelihood of a knee-jerk diagnosis. Avoid jumping to conclusions while considering all factors affecting a property. And from a personal note, I can tell you that if you walk the property and look for things beyond the one that the customer called you about, you will often increase your opportunity with that customer as you identify other issues that you can, in fact, help them with. Diagnostic skill builds client trust. A few closing thoughts. Your role is not just to make recommendations or even to treat problems. We're all stewards of the environment, so your role is also to make the most environmentally sound and effective recommendations. It's to correct, treat, or ameliorate conditions that pose problems for plants, but to do so selectively. Gone are the days, as they were when I was spraying for a living, where you sprayed the entire neighborhood down as you were trying to control the insect of the day. Consider the smallest doses, the least environmental impact, the longer residuals, and targeted solutions. Either we'll manage them or regulations are going to limit our options. You make the difference on your customers' properties every single day, every single time. It's up to you what you do. I'll make one more comment before opening things up to questions. I wanted to include this map just to show you where all of our regional technical people are throughout the country. So if you take a quick glance at that, you can actually go to our website. Each of these people is happy to help you with the pests, the diseases, and issues within your communities. And I would encourage you to reach out to them for advice, guidance, training, whatever you may need. So Zach, if we're still on and there are any questions, I'll be happy to work on that now.
Hey everyone, thanks for attending. Again, if you have any questions, you can type it into that little chat bubble on the control panel. There weren't any questions throughout the class, so hopefully everyone heard Rob okay. And again, we recorded this, so for anyone that wants to re-watch it, it usually takes a couple days for us to get it downloaded and up onto the website. So, be on the lookout for an email or Facebook notification saying that we have posted it, and then you can go back and watch it, share it with your friends, share it with your colleagues. But thanks again for everyone, and we'll hang on for a few more minutes to answer any questions that come up.
Zach, I can't see if anything's come up. Let me know. If not, we can bid everyone a good afternoon.
Yep, I haven't seen anything come up yet. You can always reach out to us at the office, and we can get you appropriate phone numbers. Thanks for everyone coming today. Again, it's been recorded, so we'll send out some messages saying that it's up and posted when it's up and ready. Thanks for coming today, and there are plenty more Roots to Shoots webinars coming up, so always check back with the website to find out what's coming up. So again, thanks everyone for coming. Rob, nice job today. Thanks for taking care of this. I'm sure it was very informative. With that, let's end this session and let everyone get back to their working lives.
Very good. Thank you.